Hello, my name is Dmitry and welcome to the DPLABS channel. Since Kolya and Ivan are being punished for taking acetone for biosamples and are currently standing in the corner, I have some free time, so I'll tell you about my greenhouse. This greenhouse measures 17 by 11 meters, which is about 190 square meters in area. This is the kind of single pitch design it has. The sloped roof is necessary because of the heavy snow load. The frame is made from square tubing using St. 3 steel. There you go. The greenhouse is glazed with double glazed windows. The double glazed windows were purchased from the company Gomel Glass in Belarus because their prices are much more reasonable. The double glazed windows are frameless and are mounted here in this way, with a small gap between the two double glazed windows. They are attached using 3M tape. First, everything is degreased, then attached with 3M tape. The gap between the double glazed windows is filled with Penaplex and sealed with butyl sealant for double glazed windows. After that, 2 strips of tape are applied and a stainless steel plate is pressed on with bolts. It's very sturdy, and as a result there is no thermal bridge and the profile is covered. What's good about this Gomel glass? It's inexpensive. Here, the glass is 6 millimeters thick. It has a slight greenish tint, but in our case, that doesn't matter. The total cost for this entire greenhouse, including glazing, came to about $4,500 to $5,000 with delivery. That's much cheaper than buying it in Russia. We bent these stainless steel elements ourselves at our production facility. The hardware, like these bolts and screws, is also stainless steel. This drip edge here was also made from stainless steel. So moving on, here we installed a door like this. The greenhouse is currently undergoing renovation because a number of significant shortcomings were discovered during use. One of the main issues is that we grow different agricultural crops in the same greenhouse. For example, in winter we grew greens, arugula, dill, onions, as well as tomatoes, cucumbers, melons like cantaloupe and watermelon, plus eggplants and peppers. The problem is that each crop requires its own climate conditions. For instance, cucumbers need about 70% humidity, tomatoes do best at around 40%, and watermelons need as little as 20%. Excessive humidity affects everything. As a result, the climate was unbalanced and everything grew poorly, especially the watermelons. There were a lot of fruit sets, but the flowers would fall off, and from one bed we got at most 15 watermelons and 20 melons. That's very little for such a labor-intensive process. We decided to divide the greenhouse into 3 sectors. Now I'll show you what it looks like inside. So we've divided the greenhouse into 3 sectors using these partitions. Doors will be installed here soon. And since we have independent heating, ventilation, and irrigation, humidification of all these sectors, we'll be able to adjust the temperature and humidity for each zone separately. Another drawback that was discovered during operation is significant corrosion of the black metal, especially because sometimes you have to disinfect the greenhouse using sulfur checkers and so on. Because of this, droplets of sulfuric and sulfurous acid form which eat away even galvanized metal. Here's an example. The chain's 2-per light fixture made from black steel have turned into this kind of steel. So all the zinc has been eaten away. But now we've bought stainless steel chains and we'll be replacing them. Nothing bad happened to the aluminum. Here too it's stainless steel and everything is fine. There have also been problems with the paint coating on some of the posts. Come on, I'll show you. Look, corrosion has appeared on many elements, so now I have to strip the paint and repaint them because I don't like it this way. Honestly, if I were to build again, I think I would use a fairly thick aluminum profile for the greenhouse. It wouldn't be that much more expensive, but there would be no problems with corrosion. Regarding lighting in the greenhouse, in the summer there is naturally enough lighting, even more than enough, because the glazing is very large. But still, with supplementary lighting, but still with the use of artificial lighting, we significantly increase the yield. For example, the same tomatoes can be illuminated for 18 to 19 hours. And this will greatly increase their growth. For lighting, we use LED lamps with a specific spectrum. This is what they look like. They lack the green component because, and the color turns out to be kind of fuchsia. The green component isn't needed because the leaves are green, which means they reflect green light. They don't absorb it. Now, each lamp, let me not lie, I'll tell you exactly how many watts. Mumble, mumble, mumble. Each lamp is 70 watts, and this is the kind of power supply they have for 2 lamps at once. It has intensity control via a 0 to 10 volt signal. Since the plants grow and the height of the lamps needs to be adjusted, it's set up on this kind of suspension. Everything can be raised, the carabiners can be reclipped, and as the plants grow, we raise the lighting. Now, regarding the irrigation system is organized as follows. Downstairs in the basement, we have valves that can open for each bed, and there are these kinds of drippers. These are calibrated drippers. For example, this one is 6 liters per minute. Water is delivered to each plant through these small channels. The water is preheated. We have a thermostat there. Also, later I'll show you there's a dosing pump for fertilizers. That's it. Now, regarding the organization of the beds themselves, the beds look like this kind of tub, which is waterproofed. A little gravel is poured at the bottom, and there is drainage so that excess moisture goes into the sewer, preventing rot and decay. Also, each bed is equipped with underfloor heating so the soil can be warmed. Right here, there's a separate soil sensor. Here it is. I'm not going to pull it out. It's in a stainless steel tube, and we know the soil temperature. Now, about the heating and ventilation, you can see these ventilation ducts. We made them ourselves like this. And on this side, closer to the wall, we have the exhaust, and here is the intake. By default, the air is not blown outside, it circulates. And the circulating air can be either heated or cooled in the summer. If we need to, for example, if the greenhouse overheats or the humidity level gets too high or the carbon dioxide level becomes excessive, then one of the exhaust systems opens to the outside, and also louvers in the wall at the top open to allow air circulation from outside. Regarding greenhouse ventilation, the less often we ventilate the greenhouse, the better, because plants need a high level of carbon dioxide. For example, here outside the city, our CO2 level is about 250 to 300 parts per million. That's parts per million. For cucumbers, the ideal would be around 3,500. Because of this, without additional fertilizers, plant growth increases significantly. How do you get CO2 there? There are technologies. You can use dry ice or something else. Or to have organic matter decompose, I came up with the following. Let's go over here. Here we installed a cheap gas water heater. It costs about 6,000 rubles. At the bottom it's connected to the gas, and there's a circulation pump connected to the heating system and the carbon dioxide supply. We turn on the circulation pump, the heater starts working, and its exhaust goes here. So we burn propane and get carbon dioxide and water vapor. Because of this, we can significantly increase the CO2 level. This 30-liter composite cylinder lasts for about a month of operation. All right, moving on. We also have drainage set up everywhere because when working with plants, something might spill or overflow. The floor is a polyurethane coating. All right. Next, we have a lot of lamps here, and now we're going to redo everything and hang them up. Also, we need to install fans in the greenhouse to improve air circulation. They'll be placed in the gaps here and will move the air around. So what else do we have here that's interesting? This here is the water spraying system, which we use to humidify, and in the summer it cools things down really well. But we're going to redo it because it's hanging too low and needs to be mounted higher. And we need to divide it into 3 sectors because the high pressure pump isn't able to create enough pressure. Here the pressure is approximately 50 to 60 bar, which consequently gives a very fine, delicate spray. This is precisely how we've carefully set up the garden beds. I understand that there's not much space here, but this is an experimental greenhouse for my needs and my family's needs. And it's not for commercial use. Of course, there's very little free space here. If it were about 500 square meters, there would still be just one walkway, but there would be a lot more beds. That's it. In the future, I'll be filming how things go here. Basically, once we start planting and putting everything into operation, if you're interested. Now let's talk about the engineering systems. So regarding the specifications, Even when the temperature was minus 20 to 25 degrees, well, and the sun was shining strongly, the greenhouse would even overheat. By the way, the north side is just a solid wall made of sandwich panels because there's no point in having anything else on the north side. So, what else did I want to say? Here, there will be a vestibule because you can't bring dirt and all sorts of fungi into the greenhouse. That is, you have to enter here. I don't know, put on shoe covers and then go in. Right now, it was made from black metal, but now we'll redo it in aluminum because everything here rots, condensation drips, and so on. So, more about the engineering systems. Basically, in winter, let's say at night, if it's minus 25 degrees outside, then in the greenhouse, when we lower the temperature at night to about 24 degrees, it consumes about 25 kilowatts, maybe 30 at minus temperatures, which is actually not that much, I think, considering that the double glazed windows really make a difference. In the summer, I measured that since we cool it by adjusting the water temperature, it can generate up to 60 kilowatts of excess heat that needs to be removed. So all the greenhouses are heated by a heat pump. Let me show you what the engineering facility looks like from the inside. Right now, we're in the basement under the greenhouse. It's not the full width, just a part of it because of the terrain. Here we have not only the systems for the greenhouse, but also for several houses and my garage. Here is a heat pump with a capacity of 140 kilowatts using a Korean screw compressor. It operates using a ground loop that's 2.5 kilometers long, which is buried here. A solution of alcohol is circulated through the ground loop. These are the pipes from the cold circuit. Its COP is about 4 to 4.5. Right now the temperature is set to just 35 degrees according to the weather sensor because it's not that cold. By the way, it's about to start working now. There you go. Moving on. All right, moving on. Next you can see the ventilation system. Now I'll stop it. So here's the ventilation system. I've just turned it off so it doesn't make noise. There you go. There's a 5 kilowatt fan installed here, I think. Here are the air heaters and here are the air coolers. 2 of them run on running water from the warehouse. 1 is running on fruit and 3 are powered by the circuit because by the end of summer the circuit overheats a lot and there's nothing left to cool with. There's also an additional ultrasonic humidifier here which circulates air there. And from here we can see, right here you can take a look. This is exactly where the supply to the greenhouse comes from. You can see it here. And here there are individual valves for each line so we can adjust everything. So what else do we have? Well, yes, all the control systems are here. There's a computer with our software, a control module with relays, and some parts are done on Modbus as well. That's how it is. But this is the main one here, and there are backups and so on. So what else do we have here? The comprehensive outputs. The entire series thoughtfully includes essential bed heating, and here we can clearly see the various crucial valves, and over here are the robust gates. By carefully and precisely adjusting these components, we effectively manage our system. We also have 1 dedicated dosing pump, a highly efficient and integrated mixing unit, which are all vital parts of this sophisticated setup. So here we have this, right here. This is our irrigation system. Here are the valves, they open. And the fertilizer mixing pump, it operates using the flow of liquid. Right now, it is placed in a bucket with fertilizer, and you can adjust how many liters per minute to supply. And it is supplied. A high-pressure fertilizer mixture. Here is a high-pressure compressor for spraying water. When we spray, the water must be very clean after reverse osmosis, otherwise even the smallest particles will clog the nozzles. For this, there is a water purification and softening system, then a reverse osmosis membrane and a storage tank for this clean water. Everything is supplied from it. Now regarding the energy consumption of the greenhouse. In summer, of course, it doesn't need to be heated, only cooled. And it generates a maximum of 65 kilowatts of heat. That's based on the temperature difference of the cooling water. And in winter, even at minus 30, I think it consumed a maximum of about 15 kilowatt hours. You could say that the average consumption during the heating season is 7 to 8 kilowatt hours. In winter, even when it's cold, but the sun is shining brightly, sometimes the greenhouse still needs to be cooled. And considering that I heat it with a heat pump, my energy costs aren't that high. I pay only 1/4 of the produced thermal energy for electricity. That's how it is, ladies and gentlemen. All the best. Well, if you liked it, let me know in the comments. If you're interested, next time I'll continue filming about my greenhouse. So we'll cover how we plant the crops, which ones, how we harvest, and what changes we'll be making. All the best.